Klein Tools 1000 volts insulated screwdrivers can be found in several locations. Firstly, check the tool department at your local Home Depot. It's been reported that they carry the 1000 volts model. Secondly, online retailers are a great place to look. Amazon.com carries the Klein Tools 1000 volts insulated screwdriver. You can find it by searching for Klein Tools 1000 volts insulated screwdriver on their website or by using this direct link. Thirdly, Lowe's is another option. They also sell the Klein Tools 1000 volts Phillips screwdriver. You can find it on their website. Fourthly, Grainger is an industrial supply company that carries Klein Tools products. They also sell the Klein Tools Phillips screwdriver. These screwdrivers are designed for working with electricity and are insulated to protect against electric shock. The 1000 volts rating indicates the maximum voltage the screwdriver is designed to withstand. When working with electrical circuits, it is crucial to use insulated tools that are rated for the voltage you are working with. Always ensure the tool is in good condition and free from any damage before use. Inspect the insulation for any cracks, tears, or other signs of wear. If the insulation is damaged, do not use the tool. It's also important to follow all safety precautions when working with electricity, including turning off the power to the circuit you are working on and use appropriate personal protective equipment such as gloves and eye protection. The Klein Tools insulated screwdrivers are tested to meet or exceed industry standards for safety. However, it's important to remember that no tool can completely eliminate the risk of electric shock. Always exercise caution and follow safe work practices when working with electricity. Remember that voltage is a measure of electrical potential difference, essentially the electrical pressure that drives current through a circuit. A higher voltage means a greater potential for electrical shock. Amperage, on the other hand, is a measure of electrical current, the flow of electrons through a circuit. Even low voltages can be dangerous if the amperage is high enough. The severity of an electric shock depends on several factors, including the voltage, amperage, duration of contact, and the path the current takes through the body. Electric shock can cause a range of injuries, from mild tingling to severe burns, cardiac arrest, and death. That is why it is absolutely crucial to use properly insulated tools and follow all safety precautions when working with electricity. Before purchasing a 1000 volts insulated screwdriver, consider the specific tasks you'll be performing. Different types of screwdrivers are designed for different types of screws, such as Phillips, slotted, and square drive. Choose a screwdriver that is appropriate for the screws you'll be working with. Also, consider the size of the screwdriver. A smaller screwdriver may be easier to use in tight spaces, while a larger screwdriver may provide more torque for driving screws. When using an insulated screwdriver, always hold it by the insulated handle. Avoid touching the metal shaft of the screwdriver, as this could create a path for electricity to flow through your body. Also, be careful not to damage the insulation on the screwdriver. Avoid using the screwdriver to pry or hammer, as this could crack or tear the insulation. If you are unsure about how to use an insulated screwdriver safely, consult with a qualified electrician or other expert. They can provide you with training and guidance on safe work practices. Remember, electricity is a powerful force that can be dangerous if not handled properly. By using properly insulated tools, following safety precautions, and seeking expert advice when needed, you can minimize the risk of electric shock and work safely with electricity. If you're working on a branch circuit, it's essential to understand the components involved and their functions. A branch circuit is the portion of an electrical system that extends from the last overcurrent protective device, such as a circuit breaker or fuse, to the electrical devices being powered. These devices can include lights, receptacles, and appliances. Circuit breakers and fuses are designed to protect the circuit from overloads and short circuits. Overloads occur when the circuit is drawing more current than it is designed to handle, which can cause the wires to overheat and potentially start a fire. Short circuits occur when there is an unintended connection between two conductors in the circuit, which can cause a large surge of current. The overcurrent protective device will trip or blow, interrupting the flow of current and preventing damage to the circuit. The size of the circuit breaker or fuse is determined by the ampacity of the wires in the circuit. Ampacity is the maximum amount of current that a conductor can carry continuously without exceeding its temperature rating. The National Electrical Code, or NEC, provides tables that specify the ampacity of different types of conductors based on their size and insulation type. For example, NEC Table 310.15b16 lists the allowable ampacities of insulated conductors rated up to 600 volts, not more than 3 conductors in a raceway or cable or earth, based on ambient temperature. It is important to select the correct size circuit breaker or fuse for the circuit to ensure that it is properly protected. If the circuit breaker or fuse is too large, it will not trip or blow in the event of an overload or short circuit, which could lead to a fire. If the circuit breaker or fuse is too small, it will trip or blow unnecessarily, which can be inconvenient. When working on a branch circuit, it's also important to identify the conductors correctly. In a typical 120-volt circuit, there are 3 conductors: a hot wire, a neutral wire, and a ground wire. The hot wire carries the current from the source to the electrical device. The neutral wire provides a return path for the current. The ground wire provides a path for fault current to flow back to the source in the event of a ground fault, which can help to prevent electric shock. The hot wire is typically black or red, the neutral wire is typically white, and the ground wire is typically green or bare copper. It's important to follow these color codes when wiring a circuit to ensure that it is wired correctly. It's also important to use the correct type of wiring for the circuit. The most common type of wiring used in residential wiring is non-metallic sheath cable, which is also known as Romex. Romex consists of 2 or more insulated conductors wrapped in a plastic sheath. The size of the wiring is determined by the ampacity of the circuit. For example, a 15 amp circuit typically uses 14 gauge wiring, while a 20 amp circuit typically uses 12 gauge wiring. It is important to use the correct size wiring for the circuit to ensure that it can safely carry the current. When making connections in a branch circuit, it's important to use the correct type of connectors. Wire connectors, such as wire nuts, are used to connect 2 or more wires together. They are available in different sizes to accommodate different wire gauges. It's important to use the correct size wire connector for the wires you are connecting. Also, be sure to twist the wires together tightly before installing the wire connector to ensure a good electrical connection. Receptacles, or outlets, are used to provide a point of connection for electrical devices. They are available in different configurations to accommodate different types of plugs. The most common type of receptacle is the duplex receptacle, which has 2 outlets. It's important to use the correct type of receptacle for the circuit. For example, a 15 amps receptacle should be used on a 15 amp circuit, while a 20 amps receptacle should be used on a 20 amp circuit. When installing a receptacle, be sure to connect the wires to the correct terminals. The hot wire should be connected to the brass terminal, the neutral wire should be connected to the silver terminal, and the ground wire should be connected to the green terminal. It's also important to properly ground the receptacle to ensure that it is safe. Lighting fixtures are used to provide illumination. They are available in different types and styles, such as incandescent, fluorescent, and LED. It's important to choose a lighting fixture that is appropriate for the application. For example, a bright light may be needed in a work area, while a dimmer light may be preferred in a bedroom. When installing a lighting fixture, be sure to connect the wires to the correct terminals. The hot wire should be connected to the black wire in the fixture, the neutral wire should be connected to the white wire in the fixture, and the ground wire should be connected to the green or bare copper wire in the fixture. It's also important to properly ground the lighting fixture to ensure that it is safe. Electrical boxes are used to enclose and protect electrical connections. They are available in different sizes and shapes, such as square, rectangular, and round. It's important to use the correct size and type of electrical box for the application. For example, a larger box may be needed to accommodate multiple wires or devices. When installing an electrical box, be sure to secure it properly to the wall or ceiling. Also, be sure to leave enough wire length inside the box to make connections easily. When working on any electrical circuit, it's always important to follow safe work practices. Always turn off the power to the circuit before working on it. Use a voltage tester to verify that the power is off before touching any wires or devices. Wear appropriate personal protective equipment, such as safety glasses and insulated gloves. Work in a well-lit area. Avoid working in damp or wet conditions. If you're not comfortable working on electrical circuits, consult with a qualified electrician. They can provide you with assistance and guidance. Remember, electricity is a powerful force that can be dangerous if not handled properly. By following safe work practices and using the correct tools and materials, you can minimize the risk of electric shock and work safely with electricity. It is essential to understand the importance of proper grounding in electrical systems. Grounding provides a low-resistance path for fault current to flow back to the source in the event of a ground fault. This helps to trip the circuit breaker or blow the fuse, interrupting the flow of current and preventing electric shock. The grounding system consists of several components, including the grounding electrode, the grounding electrode conductor, and the equipment grounding conductor. The grounding electrode is a metal rod, pipe, or plate that is buried in the earth. It provides a connection to the earth, which helps to stabilize the voltage of the electrical system and provide a path for fault current to flow. The grounding electrode conductor connects the grounding electrode to the neutral busbar in the electrical panel. The equipment grounding conductor connects the metal enclosures of electrical equipment, such as appliances and lighting fixtures, to the grounding system. This provides a path for fault current to flow back to the source in the event of a ground fault. When a ground fault occurs, the fault current will flow through the equipment grounding conductor back to the grounding electrode and then back to the source through the grounding electrode conductor. This will cause the circuit breaker to trip or the fuse to blow, interrupting the flow of current and preventing electric shock. It is important to ensure that the grounding system is properly installed and maintained. The grounding electrode should be buried deep enough to reach moist soil. The grounding electrode conductor and equipment grounding conductor should be sized according to the NEC. The connections between the grounding conductors and the grounding electrode and equipment should be tight and corrosion-free. Regular inspections of the grounding system should be performed to ensure that it is in good condition. If any problems are found, they should be corrected immediately. Ground fault circuit interrupters, or GFCIs, are another important safety device that can help to prevent electric shock. GFCIs are designed to detect small imbalances in the current flowing through a circuit. If an imbalance is detected, the GFCI will trip, interrupting the flow of current and preventing electric shock. GFCIs are typically installed in areas where there is a risk of water exposure, such as bathrooms, kitchens, and outdoor areas. They are also recommended for use with portable tools and appliances. When using a GFCI, it is important to test it regularly to ensure that it is working properly. Most GFCIs have a test button that can be used to simulate a ground fault. When the test button is pressed, the GFCI should trip. If the GFCI does not trip, it should be replaced. Surge protectors are another important device that can help to protect electrical equipment from damage caused by voltage surges. Voltage surges are sudden increases in voltage that can damage sensitive electronic equipment. Surge protectors work by diverting the excess voltage to ground, protecting the equipment from damage. Surge protectors are typically installed at the service entrance of a building. They can also be installed at individual outlets to protect specific pieces of equipment. When selecting a surge protector, it is important to choose one that is rated for the voltage and current of the circuit. The surge protector should also have a clamping voltage that is low enough to protect the equipment being protected. Regular inspections of electrical systems are important to ensure that they are safe and in good condition. Inspections should be performed by a qualified electrician. The electrician will check for any signs of damage or wear, such as frayed wires, cracked insulation, or loose connections. They will also test the grounding system and GFCIs to ensure that they are working properly. Any problems that are found should be corrected immediately. Proper maintenance of electrical systems is essential to ensure that they are safe and reliable. Regular maintenance tasks include tightening loose connections, replacing damaged wires or devices, and cleaning electrical equipment. It is also important to keep electrical equipment free from dust and debris. Dust and debris can accumulate on electrical equipment and cause it to overheat, which can lead to a fire. Working with electricity can be dangerous, but by following safe work practices and using the correct tools and materials, you can minimize the risk of electric shock and work safely with electricity.